All right, in this lesson, we are going to be solving radical equations. And so before we start, sometimes you might see a radical written as a rational exponent. So if you see a 1/2 power, that's the exact same thing as square root. If you see a 1/3 power, that's the same thing as cube root. Okay, and so when you're solving any radical equation, your first step is to isolate the radical, and then you are going to cancel the radical by doing the inverse operation. So for square root, you are going to square both sides. For cube root, you're going to cube both sides to get rid of the radical. Okay, and so after the radical is gone, you're going to isolate the variable to solve the equation. And so something we have to remember for square root is that you must check for extraneous solutions. Check for extraneous solutions. Okay, and so the main thing you have to remember is that square root cannot equal a negative number. A positive square root cannot equal a negative number. Okay, and so looking at this first example, I have square root of x equals 9. So we can square both sides and we would get x equals 81. Okay, a lot of people accidentally square root to both sides. We're already square rooting, so don't say x equals 3. We have to square both sides. That would be the inverse operation. Okay, so number 2 is an example that has no solution because a positive square root cannot equal a negative number. Okay, don't confuse this with the square root property that says if I have x squared equals some number, then x equals the positive or negative square root of that number. We're not trying to do square root as an inverse operation. We are given a positive square root, not a plus or minus square root, a positive square root. So if you see square root equal to negative, you don't square both sides because you're going to get an extraneous solution. There is no solution to this problem. Okay, next I'm seeing a 1/2 power. If you want, you can go ahead and write that as a radical of square root. It's the same thing. And then step 1 is to isolate the radical. So I'm going to add 5 to both sides. And then we are going to square both sides. Okay, and so x equals 400. Okay, next we have a lot more going on, but your first step is still to isolate the radical. And so here is the radical, and then we have to get rid of the things outside. Your first step is to add 8. So that leaves us with the square root of 1 minus 4x equals 4. Okay, so we're taking care of this negative, so don't call it a no solution case until you've isolated the radical. Next step is we are ready to divide by the 2. And so here I have square root equal to a positive number, so we can keep going. We're ready to square both sides to get rid of the square root. And then now we're ready to isolate our variable. So our first step is to subtract 1 from both sides. And then we can divide by the negative 4. So my final answer would be negative 3/4. All right, on this next example, we have a square root expression equal to a linear expression, meaning we have variables on both sides. And so this is where you really have to check for extraneous solutions. And so step 1, we still have to isolate the radical. It's already isolated, so we are ready to square both sides. Okay, and so when I square the left side, the square root and the square cancel, leaving me with just 21x plus 1. But on the right side, I have this binomial squared. X plus 5 squared is the same as x plus 5 times x plus 5. Write it out like that because often it's tempting to distribute that. You cannot distribute that, so do not fall for that. People make that mistake every time, and then you're going to get a very wrong answer. Okay, and so by writing it out twice, it prompts you to FOIL it. X times x is x squared. X times 5 is 5x. 5 times x is 5x. And then 5 times 5 is 25. Okay, I can combine these like terms. So I get x squared plus 10x plus 25. And then on the left, I still have that 21x plus 1. Okay, and so now you can see we're working with a quadratic equation. Anytime you're working with a quadratic equation, get every term on one side and try to factor. So I am going to move everything to the positive x squared side. Okay, so that leaves me with x squared minus 11x plus 24. Still equals 0. And so now to factor this, we need to find two numbers that multiply to 24, but add to negative 11. Okay, that would be negative 8 and negative 3. Those would multiply to positive 24, but add to negative 11. And so my factors are x minus 8 and x minus 3. If you have a quadratic that's not factorable, you did something wrong. We're going to give you a quadratic that's factorable. You should not have to use the quadratic formula. And if you're using AI, they typically use quadratic formula for everything. And so don't use that as your method. Try to factor first. That's going to be the most efficient way to solve this problem. So now we can set each factor equal to 0. And so one of our factors is x equals 8, or one of our solutions, and then the other solution is x equals 3. Okay, so now before you commit to those as your final answer, you have to go back to your original equation before you squared things, the one with the radical in it, and you have to check to see if those actually work. So we are going to plug that in to our original equation, which says 21 times x plus 1 equals x plus 5. Okay, and so we're going to check both values. And so first we're going to plug in the 8, and then we're going to plug in the 3. So when I plug in the 8, 21 times 8 is 168. And then we have the plus 1, which is 169. Square root of 169 is 13. On the right side, 8 plus 5 is 13. And so we end up with 13 equals 13. So x equals 8 is one of our solutions. On the right side, 21 times 3 is 63 plus the 1, which is square root of 64, which gives me 8. And then on the right side, I get 3 plus 5, which is also 8. And so x equals 3 is also one of our solutions. Okay, on the number 6, it's a similar situation. We're seeing x on both sides, so we are going to have to check for extraneous solutions, but we're not ready to square both sides just yet. You still need to isolate the radical. Okay, so your first step here is to add 2 to both sides, which would give me square root of x plus 14 equals x plus 2. Now you're ready to square both sides. Square root and square cancel, giving me x plus 14 equals, and then we have x plus 2, x plus 2. Remember, we have to FOIL that out. Do not distribute your square. So x squared plus 2x plus 2x plus 4. Okay, we're dealing with another quadratic equation, so we have to get everything on the positive x squared side. Oh, I didn't combine my like terms yet. So combine these like terms. You don't have to do that first, it just keeps it simpler. Now get everything on the positive x squared side. So now we have x squared plus 3x plus 10. So now we need two numbers that multiply to 10, but add to 3. Oh, just kidding, that's negative 10. So two numbers that multiply to negative 10 are positive 5 and negative 2, and then those would still add to positive 3. So my factors are x plus 5 and x minus 2. And so my solutions, when I set each of those factors equal to 0, are x equals negative 5 and x equals positive 2. Okay, now remember, we have to check this. These are the most tedious to solve. And so you can go back to the equation where we isolated the square root, or you can go back to the original equation. I'll just go back to the original one. And so write that down twice because you're going to plug in both. So that's square root of x plus 14, and then a minus 2 equals x. Okay, and so we are going to substitute the x with a value. Okay, so in the first case, we're plugging in the negative 5, which would give me a square root of 9 and then a minus 2 equals negative 5, which gives me 3 minus 2 equals a negative 5, which gives me 1 equals negative 5. That is not true. And so x equals negative 5 is an extraneous solution. Okay, so now we're checking the 2. And so here I get square root of 16 minus 2 equals 2, which gives me 4 minus 2 equals 2, which gives me 2 equals 2, which does work. So your only solution for this equation is x equals 2, but you would still need to identify the negative 5 as an extraneous solution. All right, on number 7, we still have variables on both sides, but notice we also have square roots on both sides. That actually makes this very easy because when we square both sides, both square roots cancel, and we don't end up having to square a binomial. We just have a linear equation to solve. And so this one, you really don't have to check for extraneous solutions. The extraneous solutions really only come up when you have variables on both sides where one is not a radical, not under a radical, okay? And so that's like 5 and 6. Check for extraneous solutions. Okay, when you have a variable on both sides and one is not under a radical. The other thing you have to watch out for with square root is just making sure it doesn't equal a negative. In that case, you shouldn't even be solving. You should say no solution. Okay, so for here, the radicals cancel out, leaving me with a linear equation. So I'm going to subtract x from both sides. Oh, that's x minus 6 equals 3. And then add 6, and we get x equals 9. And of course, you could plug that in and see that you are left with a true equation. It's always a good idea, especially on a test or quiz, but not absolutely necessary as it is for these cases. Okay, now we're going to get into some cube root functions. Okay, everything so far has been a square root. Now I know I am dealing with a cube root because of this 3 in the index. So instead of squaring both sides, we have to cube both sides to get rid of that radical. And so here, the cube root and the cube cancel, giving me 5x equals 8, divide by 5, and then x equals 8/5. Okay, here, same idea, cube both sides. So we get x minus 2 equals 125. Add 2 to both sides, x equals 127. Okay, here they are putting a 1/3 power. That is the same thing as cube root. So if you want to rewrite it, you can. And so now we can see we need to cube both sides. Okay, and so you can kind of see if you were to cube both sides here, that 1/3 power times the 3 power, you would multiply those exponents and they cancel. So that's why a cube root and a cube cancel, That's why a 1/3 power and a cube root are the same thing. They're both the inverse of cube. Okay, so that gives me x plus 6 equals 27. Subtract 6, we get x equals 21. Okay, here we're not ready to do the inverse operation until we isolate our cube root. Okay, so first step, add your 4. And then be careful, you see this 2 in front of the parentheses. It's tempting to kind of distribute that, but remember that parentheses, that's your cube root. Okay, and so if you need to write it as a cube root, as a radical notation, so you don't accidentally distribute the 2, do that. Okay, we have to divide by 2. That does not affect the 7x minus 1. That's under the cube root. Now we are ready to cube both sides. And so that gives me 7x minus 1 equals 8. Now we have a linear equation, add 1, divide by 7, so x equals 9/7. Okay, here, isolate your cube root. And then when you're writing your cube root, make sure it doesn't look like you're multiplying by 3. Make sure that 3 is small. And then divide by 4. So I have cube root of 3x equals 3. Now we are ready to cube both sides. And so 3x equals 27. Divide by 3. We get x equals 9. Okay, here, similar to the square root situation, I have a cube root equal to another cube root. And so when we cube both sides, they both go away, and we're left with a linear equation. So cube root's really easy. And then we can subtract x from both sides. And then subtract 24 from both sides. Divide by 2, and we get x equals negative 15. All right, so looking at this last one, it says, Jeremy and Serge were comparing answers on last night's homework. This is their work. Who did the problem correctly? If they did the problem incorrectly, explain their mistake. Okay, so looking at Serge's work, it looks like he subtracted 5 from both sides. Good first step. And then when he squared both sides, he got 196. And then he subtracted 1 from both sides and got 195, then divided by 3 and got x equals 65. That is correct. So looking at Jeremy's work, it looks like he went ahead and tried to square both sides and then distributed the square to cancel the radical. You can't do that. You would have to FOIL that. And so Jeremy's work is incorrect. And that's because at this step, can't square both sides yet. And if you do, you would have to FOIL that out. That would be a binomial situation. And so can't square both sides like that. Don't do that.